States of equilibrium. When a body is at rest, all the forces acting upon it balance one another, and the body is said to be in equilibrium. So, for bodies that are in equilibrium, there is no net force. Three states of equilibrium are in existence. A body can be in stable equilibrium, neutral equilibrium, or unstable equilibrium. So in this particular subtopic, we are going to discuss each of these states, starting with the stable equilibrium. These three states of equilibrium can be demonstrated using a cone in the lab. So for the stable equilibrium, we allow the cone to rest on its base as shown in diagram 1. A slight horizontal force F is then applied and its effect observed. So it is observed that when the force F is applied slightly and then withdrawn, then the cone is tilted through a small angle, but when the force is withdrawn, the body, or the cone in this case, falls back to its initial position. When F is withdrawn. It is important to note in this case that we have a broad base and the center of gravity of the cone is very low. So when the slight push is given, the center of gravity gets raised, but it then falls back to make the center of gravity as low as possible. When F is slightly applied, COG gets raised, but it falls back to make the COG as low as possible. Neutral equilibrium. In neutral equilibrium, the cone is allowed to rest on the table horizontally so that the center of gravity acts downwards and the weight, which is the force in this case, acts from the center vertically downwards on the table. So again, in this case, we can still apply a slight force to observe its effect. So when the cone is laid on its side, as shown in this case, and the force is applied on it, it is noticed that no matter how big the force of displacement is, the position of COG does not change. COG position remains the same. So in equilibrium, in a neutral equilibrium state, the COG remains the same irrespective of how big the force of displacement may be. So when F is applied, the cone acquires a position that is similar to the initial one. Is similar to the initial one. That is for neutral equilibrium state. Let us now look at unstable state. For unstable state, we again apply a slight force F while placing the cone on its tip. So we allow the cone to balance on its tip. Then we apply a small sideway force. So the small sideway force pushes the vertical line through the center of gravity to fall outside the base. F pushes the vertical line we are talking about is the line of action of the center of the weight and the center of gravity. F pushes the vertical line to fall outside the base. And the moment of the force due to gravity will cause the cone to fall. So the cone falls, or we say that the cone acquires a new position. It acquires a new position that is completely different to the initial position.